Right, so I've updated my 3D model actually because it had the other coils in the rectangular coils before. Because I don't use those now. That was this one with all the rectangular coils that were in the side. Yeah, it turned out that using all those it wasn't very efficient. So, oh heck, I can't put anything away. So anyway, this is the actual current design actually, but as you can see from my stage, I've only got 2 stages. And the reason for that is to minimise the vibration and balance problems that you might get with the shaft bending at high speed. So there's something I wanted to mention actually about rotors and everything, because a lot of people seem, oops, damn it, what am I doing? Knocking everything over it. I'll just get my rotor if I can get it without dropping it. Right, this thing's heavy. It's very heavy. There's a lot of magnet. Just a minute, let's see. Just to give you an idea, let's weigh it. I'll show you out. There's a lot of magnets in there. Forget my scale. I can't put the magnets near the scale because it interferes. So what I have to do is I wish I would stop saying that word. It's not basically at all. Yeah, I do tend to waffle a bit too much. So, right, let's put this on here because I want this to be zeroed out, because these magnets have got to be a long way away from the scale. Otherwise, the magnets themselves will scale and offset and the readings. Anyway, let's just find out first of all if it's going to be okay with this on. Right, let me just hold the magnet above it, see if it affects the scale. Nope, it's not affecting it, so I should be able to put that on there. It's 213.9 grams. That's just that one rotor, and there's 2 of those in my generator, pulse motor generator, whatever. So anyway, what I was trying to explain is that a lot of the designs I've seen on the internet, and I'm not getting at anybody in any way whatsoever, but a lot of the designs, the magnets are really close together, and that's a problem. I mean, if you've just got I've made the same mistake with my early designs. Let me just let's just go in my cupboard a minute. Let's see what I've got in here. Right, just get a disc. Right. The problem with the disc rotor system is that the flux tends to basically collapse in on itself, because what the problem, if you've got a magnet in there and it's north facing up and you've got one over here with south facing up, the field basically loops and it collapses, so you don't actually get a lot of magnetic flux being ejected out. So you don't get a very good coupling, and that's a problem, because if you don't amplify the field, then you're going to lose a lot of energy. So I've got this magnetic gauge made, which all it is basically some magnets repelling each other. That's all it is, and I use this on all my testing and everything. But when you get to, I'm just going to move this out of the way before it goes and sticks on everything. So if you get to, I'm trying to make this short because my battery might die on me. You get 2 magnets, right, like this, and you put a north, let's see, let's just put 2 side by side. Right, so these magnets, basically the same pole is basically coming out of both of them. You can see we'll get a lot of deflection on the gauge, on this gauge, and the deflection is quite high. we get quite a good deflection. But when you add more, my rotor system, my current rotor system, when you've got 3 in series, you'll see that the gain is actually much better. I mean, the middle is actually a lot stronger there than even stronger if you push them together, actually, because they don't want to be pushed together, because they want to push themselves apart. But when you push them together, hang on a minute, I need to put the phone on this stand, otherwise I can't really show you properly because I can't hold it. Just a minute. So if you want to amplify the magnetic field, something just stuck to the magnet drum. So if I put them all on like this, right, and I get this gauge above it. Now, as I push these together, the magnetic field. Oh, shucks! Where's that gone? Oops. Yeah. That just flew across the room. Oops! Now the phone fell over. Hang on a minute. I don't want to kill the stream. I'll try not to. Let me just put a weight on it or something. Right. The flipping thing just flew across the room. That's what happens. See, it's on metal. It really shouldn't be on metal because it's interfering with it. You see, ideally you don't want it on a metal background. But when you push them together, you get a stronger field, basically. Now, to prove that, if you reverse, if you put it, so it's north, south, north, like that. Right, so we reverse them. This one in the middle is reversed, the other two are the same. What we end up with is a much weaker, field. You're strong there, but it obviously goes down there and it's strong there. But you get a stronger field when you actually have more magnets. That's why I use the drum the way that it's configured. It's easy to show you on the drum, really. Let's just take that off there. But I had the same problems myself when I was making these magnet generator things, because the problem was the field tended to collapse. And with this drum, because the magnets are at the same pole all there, you get a really strong. That's the wrong pole actually. No, I want that pole, that one. You can see how much further this. Oh, actually should be horizontal so it can see it better, but it's actually a lot stronger in the middle than it is on the sides, because the field is focused. I don't know if you can see that on my camera. Oh, I need to be further back. Actually, I'm gonna have to pick the phone up because it's not working. I can't show you properly. This thing's not really working very well. I'll turn it around. So that's pulling on there. I'm trying to hold this and do it and show you at the same time. It's a bit fiddly. It wants to spin around, you see. Right. So stop spinning. Right. So if you can see, we've got we've got a lot of elevation right there. It's about halfway up, which is a lot more flux really than what we would see near the edges. Really, I mean, but anyway, I'm going on. I'm waffling a bit too much. I just want to try and give an update, really. So anyway, I've been doing my coils, and what I've done is I put copper tape. I put copper tape, which is solderable copper sticky tape, onto the ends of the bobbins, so I can basically worry about the wires breaking off the coils, because I didn't want to. That's the thing that happened a few times. So I'll put the copper sticky back tape onto the sides, so that it's basically in 2 rows. So I've got a row of copper on each side. Then I put some ABS plastic with acetone melted on the ends to anchor the end. I solder 2 wires onto these. So now I've got I've got a set of coils for my trigger circuit, which is going to be installed later today or something, hopefully. And since I made the last video, by adjusting the coils, by actually getting the coils in the right positions on the around the rotor. That drum I was just showing you over there, that one. By positioning the right, I managed to get the current down to 290 milliamps at 7.2 volts or something. So that's pretty good. And there was a lot of torque. And I'll explain that as well, because if you actually, let's just get this rotor magnet again. Let's get this rotary system again. Right, if you're actually pulsing these coils, if you pulse these magnets, I mean, with a coil, and you're directly overhead. So let me just get a weak magnet or something. I don't want a really strong one because it's gonna. Right, so this is difficult to do. I'm just gonna have to. I need my stand again. Hang on a minute. Let me just reverse it so it's pointing up. Put it on my stand. Right, I'm gonna have to try and. I need to put a weight on it so it doesn't fall over again. So it's pointed up. Oh, that one's broken. Must have dropped it at some point. So let me just hold this up so we're in the light. So these magnets here are a coil sending a pulse of energy. So I'll put it underneath, right? Now it's actually pulled that pole down towards it. Now if I turn it, the magnets around, we're pushing now against that rotor. Nearly all of the forces are directed straight up. So the rotors basically push directly opposite each other. It's not actually, the energy is not being used to create torque. I can hardly feel any torque at all, because in top dead center, all you do is wasting energy by pushing it right there. What you need is it right in between the two poles, when the two poles, where it's pushing on one pole and pulling on the other, because that's what the maximum torque area is, right in between the poles, which is unlike a generator. You want to be directly overhead, because that's the top of that's the top of a waveform. That's the peak, and that's the trough. So one magnet gives you your maximum peak, the other one gives you a trough. But when you're in between, it's a different way when you're actually using it as a motor. When you put it there, that's pushing really hard on there, really hard, and because it's pushing on this side, and it's actually pulling on this side, so you get the maximum torque there. So if I put that there and I let go of this, it's hard to do this, actually. You have to bear with me, because I'm trying to balance this without it flying out my hand. I need to hold it and I can't hold it properly. It wants to spin. You see it jumped there. Now that's where you get the maximum, and obviously once you get to the other magnet, it's pulling right on it. So you want to turn your power off before it gets to that top of the center, basically, so you get maximum torque. So take the stand off a minute. So when it's pulling there and it's actually pushing right there, so basically the trigger point needs to be right just past top dead center, so it's pushing it away and pulling on the next one, and that's when you get the current consumption right down really low. Actually, can get it really low. So that's pulling on that one. Right, with that in that position, so just had this magnet around in my hand, it moved. You see that? That's how sensitive it is. I'm going to come straight down on it. You see it move pretty fast. Well, if you pulse it when you top dead center, that's useless. I mean, you're just wasting energy. Anyway, I just wanted to cover that. Oh yeah, the flipping camera's pointing up, isn't it? I forgot. So you wouldn't have seen that. Oops. Yeah. So right. So that's top dead center. Bring the magnet down from a high altitude, and it will push, and then it will grab the next magnet. So that's pushing and pull at the same time, basically, because it's pushing against one, pulling on another. And we can just rotate the magnets, and you can see the effect on it, really. Oops. Anyway, don't know what I'm waffling on about, but I'm just just not explain it. Anyway, so I've been doing the coils. I wound these a few weeks ago, probably a month or two back. I've just put basically copper strips on there, and I can solder my wires directly on. And these two coils, these two are going to be for, they say, the trigger on in series, and these two are going to be for the trigger off. So I've got two sets. So I'll get my voltage on the input circuit, which will be a lot better, and I don't have to flick it and spin it up so fast, because it will be very difficult to spin this really fast with just that little pulley sticking out. So it will start a lot easier once I get these coils in. I'm just letting them dry a bit, because I put some plastic stuff on there and I want it to dry out a bit. Then I'm going to basically fit them in these slots here, basically like that, and then we're going to solder some wires on. There was something else I was going to, oh yeah, I've updated the diagram a little bit, because I thought, well, there might be a situation where, I'll move these coils out of the way, there might be a situation when the input signal is weak still. So I've added the bit that I've got on the breadboard, actually, the part that's on the breadboard that I didn't really put in the diagram. It doesn't have to be there. I could bypass it, or I don't even have to add it when I build the circuit board if I don't want it. But basically, a capacitor on the input in series with a resistor, and then another diode from the actual AC ground, which is to this resistor, to the ground, to actual ground, and that just creates a voltage doubler. That's a voltage doubler circuit. Basically, it just improves the signal. The signal on the input stage, so it will start more easily. If the voltage is quite low, it just doubles the input voltage. And I've got a voltage clamp down here, and that just makes sure that we don't oversaturate the actual main transistor. So these two diodes basically clamp the voltage so that it doesn't get above 0.7 volts. And it's all through resistors, through these trimmers and everything, so we shouldn't overdrive anything. And because if we short the out and probably short them out and blow them or whatever. So I've got resistors in series, which is a 470 ohm up here, and same on the minus volts, the plus volts. As I say, this voltage doubler section doesn't have to be there, but I thought I wanted to add it because it might be useful. It's better to have more than not enough, if you know what I mean. Anyway, so I've got I've got the coils installed to drive it underneath. I put them in down at the bottom, and I've put a wire connecting them so I can connect straight to the coils. That's already in there, and with two coils to drive the rotor, each coil is 5 ohms, so we actually have a 10 ohm. I'll put my meter on ohms. I'll turn this on. So we actually have, oh, just a minute, I need to put my clips on. It'd be easier. Let's just stick these in here. Get on there. Right, it's just easier when I'm doing this. So if I clip this onto my coil, you'll see that we've got basically 10 ohms. So if I click that on here, oh, come on. I keep having problems with these clips. Right, get on there, and it's because the cable tied together and they're just awkward. Just a minute. I can't do this with one hand. Trouble with holding the phone. Right. Stay on that. This is ridiculous. It's like a flipping spider. Just a minute, hang on. It won't stay in one place. I'm going to hold it with my finger a minute, hang on. Right, I've got one on there. Can't get the other one now. They keep falling off the clip. That's annoying. Right, so get this other one on. If it doesn't keep moving away from me when I'm I've got both of them clipped on now. So we have 10.2 ohms on the coil. So yeah, before I got the current consumption down to 2. That was with a 5 ohm coil load, down to 290 milliamps. So basically, with 2 coils in series, that current's going to be half that, but we'll need more voltage. So to compensate for 7.2 volts input, I'm probably going to need 15 volts. Oh, let me think. 2 times 7. What's that? 14 volts basically. So we'll need 14 volts to drive the coil, and it should be about the same current. It should be. It'll be definitely more torque as well because we're using 2 instead of just 1. So I'll take that off. Come off. No, it won't come off. I don't believe this. Right. It's got me. Right. Okay. So, right. I don't know why my nose is running. I can't be getting another cold. Right. Okay. So that's a little update. Are we still live? 22 minutes. God, all that waffle. Yeah. Okay, so that's all for now. I'm just letting some glue dry basically, and I can pop the 4 coils in, and then basically it's just a question of clipping these wires into the breadboard over there and having a test run. I could do it now, but I don't want to do it now because I don't want my finger marks all in the plastic. And also it's that stuff I stuck on there, it's ABS melted in acetone, and you can see that it's pinky stuff there, and it's squidgy, and like it's very squidgy, and I just don't want to start soldering wires on that when it's still there because it might catch fire or something. Yeah, I'm gonna let it dry slowly, otherwise it bubbles up and goes all weird. Right, so yeah, that's it for now.